To minus 40 seconds and counting. Wait, something's wrong. The countdown has stopped. Those words echoed through mission control at Starbase, Texas on March 3rd as millions watching around the world collectively held their breath. The highly anticipated 8th test flight of SpaceX's revolutionary Starship rocket, a critical milestone in humanity's journey to Mars, was suddenly frozen in time. After minutes of tense silence, the announcement finally came. Launch scrubbed. In those final seconds before liftoff, SpaceX engineers detected a dangerous 20-bar drop in ground spin start pressure, a critical system that powers up the massive Raptor engines. One failed ignition sequence could have turned this historic launch into a catastrophic failure. While disappointment spread across social media, Elon Musk quickly addressed the situation, tweeting, "Best to destack and inspect both stages and try again in a day or two." This cautious approach reveals just how much is at stake with each Starship test. When will we finally see Starship soar again? And what exactly went wrong in those crucial final moments? Welcome to Elon Musk 24 Hours, your premier source for the latest SpaceX breakthroughs and developments. Let's dive right in. The day had started with perfect launch conditions at Starbase. Blue skies stretched over Boca Chica, Texas, as technicians performed final checks on what would have been the 8th flight test of SpaceX's revolutionary spacecraft. The mission promised to be groundbreaking, pushing Starship closer to operational status while testing critical capabilities needed for future Mars missions. The countdown that wasn't early signs of trouble appeared before most viewers even tuned in. The original 5:30 p.m. launch time quietly shifted to 5:45 p.m., a subtle indication that engineers were already troubleshooting behind the scenes. Despite this delay, pre-flight operations appeared normal. The massive 400-foot rocket stood gleaming in the Texas sun as ground crews activated the water deluge system, successfully testing the detonation's suppression mechanisms designed to protect the launch pad. Propellant loading proceeded on a schedule. Super-cooled liquid methane and oxygen flowed into both the Super Heavy booster and Starship upper stage. The rocket vented excess pressure periodically, normal behavior during fueling operations. To the untrained eye, everything seemed perfect. Then came those fateful final moments. At T-minus 40 seconds, the countdown halted. Launch control mentioned a final launch checkout, standard language that masked the urgency of what was happening behind the scenes. Engineers had detected a sudden 20-bar drop in ground spin start pressure, a critical system responsible for initiating the Raptor engine's startup sequence. This isn't just a minor glitch, explains aerospace engineer Dr. Sarah Mitchell, who's been following Starship's development. The spin start system provides the initial momentum to the turbo pumps that feed propellants into the Raptor engines. Without proper pressure, you risk a hard start, essentially an explosion inside your engine. As minutes ticked by with no updates, tension grew among viewers worldwide. Finally, SpaceX announced the scrub. This marked only the second time in Starship's history that a launch was canceled after complete fueling, the first being the initial test flight in April 2023. Inside the technical challenge. What exactly caused this pressure drop? The answer lies in the complex dance between ground systems and rocket hardware. Elon Musk's post-scrub tweet revealed part of the story. Best to destack and inspect both stages and try again in a day or two. The decision to destack, physically separating the Starship upper stage from the Super Heavy booster, indicates a potentially serious issue requiring thorough inspection. SpaceX's abundance of caution makes sense considering what's at stake. The spin start system works by using high-pressure gas to initiate rotation in the Raptor engine's turbopumps before ignition. Think of it as the starter motor in your car. It gets everything moving before combustion takes over. When pressure suddenly dropped by 20 bars, automated safety systems immediately halted the countdown. Several potential causes exist. First, a leak in the ground support equipment could have reduced pressure in the lines feeding the rocket. Second, a faulty valve inside Super Heavy might have failed to maintain adequate pressure. Third, an obstruction or debris could have blocked critical flow paths. Fourth, extreme cryogenic temperatures might have caused unexpected contraction in components, creating gaps where pressure could escape. Adding to the complexity, launch commentators hinted at a separate issue with the Starship upper stage. This suggests multiple technical challenges converged at the worst possible moment. What's remarkable isn't that they scrubbed, notes former NASA flight director Wayne Hale, it's that their systems caught this before ignition. In the early days of spaceflight, we sometimes pushed forward with known issues. SpaceX's approach of absolute caution before risking hardware demonstrates tremendous engineering discipline. The road to redemption. While disappointing for fans, this launch scrub represents the normal development process for revolutionary aerospace systems. Each of Starship's previous test flights encountered challenges that were systematically addressed, resulting in progressively more successful missions. Just 24 hours before the scrub, SpaceX teams had completed a thorough flight readiness review, clearing the vehicle for launch. This indicates their confidence in the overall design, while highlighting how even minor issues can emerge during the final countdown. Within hours of the scrub, activity at Starbase shifted to investigation mode. Thermal cameras monitored for unexpected heat signatures that might indicate leaks. Engineers analyzed telemetry data, searching for anomalies in pressure readings, valve positions, and sensor outputs. Ground teams prepared equipment needed for destacking operations. According to SpaceX's official documentation, their current launch window extends through March 6th. This gives them a narrow time frame to identify the issue, implement fixes, and attempt another launch, all while maintaining their relentless pace of innovation. What we're witnessing is hardware development in real time, explains space industry analyst Maria Rodriguez. Traditional aerospace projects would spend years in secret testing before revealing anything to the public. SpaceX has inverted this model, allowing us to watch their iterative process unfold live. It's messy sometimes, but extraordinarily educational and ultimately faster. The next generation awaits. Even as teams work to resolve Flight 8's issues, SpaceX is simultaneously preparing for Flight 9. This reveals the company's confidence in their overall approach. They expect to resolve the current problems quickly and continue their aggressive test schedule. Flight 9 will utilize the Starship S-35 prototype paired with Super Heavy Booster B-16. Both components are already in advanced stages of preparation. B-16 successfully completed cryogenic testing on February 28, where it was filled with super cold liquid nitrogen to verify its structural integrity under extreme temperature conditions. Meanwhile, S-35's assembly reached completion by January 31st, with its distinctive payload bay already integrated with the nose cone. This parallel development approach allows SpaceX to maintain momentum even when individual flights face delays. Each new vehicle incorporates lessons learned from previous tests, creating a rapid evolution of capabilities. Flight 9 will likely refine objectives from Flight 8, focusing on improving stage separation, re-entry maneuvers, and heat shield performance. These are critical capabilities for Starship's long-term mission, creating a fully reusable transportation system capable of carrying humans to the Moon, Mars, and beyond. Based on current progress, Flight 9 appears targeted for no earlier than April 2025, though this timeline depends on how quickly SpaceX resolves the current technical challenges and secures regulatory approval. What this means for SpaceX's ambitious timeline. The stakes couldn't be higher. NASA has contracted SpaceX to develop Starship as the human landing system for the Artemis program, which aims to return humans to the lunar surface. Commercial customers, including telecommunications companies, have booked Starship launches for their next-generation satellites. And Musk himself has staked SpaceX's future on Starship's ability to establish a sustainable presence on Mars. Each technical challenge overcome brings these ambitious goals closer to reality. The pressure drop that halted Flight 8 represents one more problem to solve on the road to making life multiplanetary. What's particularly notable about this scrub is that it occurred during standard pre-flight checks, exactly when such issues should be caught. This demonstrates the maturity of SpaceX's launch procedures, even for a vehicle still under development. The history of spaceflight is written through challenges overcome, observes veteran astronaut Dr. Michael Collins. What differentiates successful programs isn't avoiding problems. It's systematically solving them while maintaining focus on the ultimate objective. By that measure, SpaceX continues to demonstrate extraordinary capability. Inside the Raptor engine revolution. At the heart of Starship's capabilities are the revolutionary Raptor engines, the most advanced methane-fueled engines ever developed. Unlike traditional rocket engines, Raptors use a full-flow stage combustion cycle that offers unprecedented efficiency. The spin-start pressure issue directly involves these engines' startup sequence. Before ignition, high-pressure gas spins up turbo pumps that will eventually force propellants into the combustion chamber. Without proper spin-start pressure, these pumps can't reach operational speed quickly enough, risking a failed ignition or damaging harmonic vibrations. With 33 Raptor engines on Super Heavy and 6 more on Starship, the complexity of managing simultaneous startup creates extraordinary engineering challenges. Each engine must ignite within milliseconds of its neighbors to prevent destructive imbalances in thrust. What SpaceX is attempting with Raptor is comparable to orchestrating a symphony where every instrument must begin perfectly on cue, explains propulsion engineer Dr. Anton Kuznetsov. The spin-start system is essentially the conductor, ensuring everyone starts together. When that system falters, the entire performance is at risk. The push to resolve these challenges comes amid increasing competition in the heavy-lift launch market. While SpaceX maintains a substantial lead with Starship's capabilities, other aerospace companies are developing their own next-generation vehicles. Each successful Starship test and each problem overcome helps solidify SpaceX's technological advantage. Despite the setback with Flight 8, confidence remains high both within SpaceX and among industry observers. The company's track record of solving complex problems, from landing orbital-class boosters to developing human-rated spacecraft, suggests this pressure anomaly will soon join the long list of challenges conquered on the road to Mars. As we await SpaceX's next launch attempt, one thing remains clear. The path to revolutionizing space travel was never meant to be easy. Each scrub launch, each technical challenge, and each engineering solution represents another step toward making humanity a multiplanetary species. The 20-bar pressure drop that halted Flight 8 isn't just a technical footnote. It's a testament to SpaceX's commitment to safety and reliability, even during testing. While we're all eager to see Starship soar again, the company's methodical approach ensures that when it does fly, it will be ready. Will the next attempt happen within days? Or will deeper inspections push the launch into mid-March? Either way, Starship's journey continues, building on 7 previous test flights and laying groundwork for missions that will one day take us beyond Earth's orbit. This is why we track every development, analyze every detail, and bring you the most comprehensive coverage of SpaceX's revolutionary spacecraft. Because when Starship finally reaches Mars, we'll all be part of that historic journey. If you found this analysis valuable, please support our mission by hitting that like button and subscribing to Elon Musk 24 Hours. Share this video with fellow space enthusiasts who appreciate the engineering brilliance behind these incredible machines. Drop your predictions for the next launch date in the comments below. We read every single one. Until next time, keep looking up. The future of space exploration is being written right now, one challenge at a time.